This problem asks us to use a definition of continuity and the limit laws to show that this function, f of x equals negative 7 times the square root of 2 minus 7, is continuous on the interval from open negative infinity to 2 closed. So this interval is from the smallest numbers up to 2 and including 2. Now, the limit laws that we're going to apply here is the one that says that when you have a limit of a constant number times a function, you can bring the constant number out in front of the limit, and the law that says when you take an even indexed root, you're taking the limit of an even indexed root like the square root, that you're allowed to bring the limit under the radical sign and apply it to the radicand, the trash under the radical sign, when you know for sure that that function under the radical sign is going to be greater or equal to 0 for all values on the interval that's given. Okay, so keep that in mind and let's start this problem. We're going to break it up into two pieces. First, for our solution, we consider a on the open interval from negative infinity to 2 open, so we're not including 2. For that, the limit as x approaches a on this open interval of f of x is a limit of negative 7 times the square root of 2 minus 7x. Now bring the negative 7 out in the front. Negative 7 out in the front. Yeah, negative 7 times the limit of the square root of 2 minus x, and as I explained, the function 2 minus x is going to be non-negative under the radical when you evaluate it for any a on this interval, so you can take the limit under the radical. And now you've got the limit of a polynomial busted up, limit of the first part minus the limit of the second part. Well, the limit of 2 is the limit of a constant, so it's just 2. The second part minus the limit as a approaches x is, well, it's a polynomial, so you do a direct substitution, it's a, but negative 7 times the square root of 2 minus a is the same as f of a. It is the y partner when x is equal to a. So we've shown that the limit as x approaches a of this function is the same as the function evaluated at this a, and that's what it means for a function to be continuous according to the definition. So we've shown that it's continuous on this open interval. Now let's do the next part. For the next part, we have to figure out what happens exactly at the endpoint a equals 2. And really here we're only interested in one-sided continuity. We only need to show that the left limit is satisfies the definition for continuity. So the limit as x approaches 2 from the negative side of the function is the limit as x approaches 2 from the negative side of negative 7 times the square root of 2 minus 7. Again, we pull out the constant negative 7 and we bring the limit under the radical and we disperse it across the two terms, and we get negative 7 times the square root of 2 minus the limit of as x approaches 2 from the negative side of x. So let's evaluate that. That's a number that's just slightly smaller than 2. So under the radical we have 2 minus a number slightly smaller than 2 gives us a number that's just slightly larger than 0. And again, we draw a number line like we have done in the past to show you how if we start at 2 and move over, we're able to get a number that's just on the right side of 0. So this is a square root of a non-negative number, which means it's 0 positive. So the square root is 0. Negative 7 times 0 is 0, and that shows us that is 0, which is the same as the function evaluated at 2. So we've shown that f is continuous at a equals 2. And therefore, we've shown that this function is continuous for the entire given interval, negative infinity to positive 2. We had to do it in two parts, but we covered all the bases there.